Febrile nonhemolytic transfusion reaction, or FNHTR, is one of many reactions that can occur after a blood transfusion. FNHTR is characterized by fever without hemolysis shortly after a blood transfusion. In this video, I'll give you my visual mnemonic to remember all the important features of FNHTR for test day. It's nighttime at the bar, and our host is whipping out her array of bar tricks. After she pours me a blood red cocktail, she adds an olive for garnish and sets the whole drink on fire. Actually, my drink serves as our anchor for febrile nonhemolytic transfusion reactions, or FNHTRs. Let me break this down. The fire and heat from the drink represents fever, since fever and fires are hot, right? The whole red olive in the drink represents the lack of hemolysis, since the olive, which looks kind of like a red blood cell, is completely intact. And finally, this drink is red like blood with a straw that reminds me of a blood transfusion. Put this together, and you get febrile, nonhemolytic transfusion reactions. And this disease is exactly what it sounds like: fever without hemolysis shortly after a transfusion. Let's move on to why these reactions happen. Do you see the tongs that bartender is using to put ice into my drink? I mean, who sticks their hand right into the ice bin? If you look closely, those tongs appear to be shaped like the letter Y, or like an antibody. This is no coincidence. This represents how FNHTR is caused by host antibodies targeting donor white blood cells. Get it? The host's antibody-shaped tongs represents host antibodies, while the white ice balls represent donor white blood cells. Put this together, and you have host antibodies against donor WBCs. Now, let's discuss what happens when these antibodies attack the WBCs. You got it, it's the age-old party trick where the host adds fire to the drink. Earlier, we said that this fire represents the fever and febrile nonhemolytic transfusion reactions. But this fire actually has a deeper meaning. It represents the inflammation resulting from cytokine release. Fever is just one of the ways the inflammatory cytokine release presents in patients. I just told you that host antibodies target white blood cells in transfused blood. This leads to destruction of white blood cells, which release the stuff inside. And if you've been paying attention to any of our videos, you would know that every white blood cell is chock full of inflammatory cytokines. So this process effectively dumps cytokines into the blood. It is these cytokines that then causes the inflammation and fever seen after transfusion. In other words, they are fiery cytokines inside the blood, just like how this fire got added to our drink. Man, that flame has made it super hot in here. See my sweaty hands reaching out for the drink? These sweaty hands should remind you that fever is one of the symptoms of FNHTR. Given that febrile is in the name of the condition, this should be obvious. We just talked about how inflammatory cytokines are released when donor white blood cells are attacked by host antibodies. These inflammatory cytokines, like IL-1 and IL-6, are also responsible for causing fever. Since febrile is in the name of the reaction, I'm not going to harp on this and we'll just move on. Next, let's return to the olive in the drink. As we mentioned earlier, this red olive is being served whole to represent how there is no hemolysis in FNHTR. This should also make sense, since the reaction is literally called febrile nonhemolytic transfusion reaction. But the real meat in this is understanding why this happens. You see, there are antibodies against donor white blood cells, and not the donor red blood cells. Therefore, damage to red blood cells really doesn't happen. This is the distinguishing feature between febrile nonhemolytic transfusion reactions and acute hemolytic transfusion reactions. Since they both are mediated by antibodies, the presence of or lack of hemolysis is dictated by whether the antibody targets the white blood cells or the red blood cells. Just remember that these drinks include whole olives, and you'll remember that there is no hemolysis in febrile nonhemolytic transfusion reactions. Lastly, take a look at that sign in the background. Happy hour from 1 to 6 p.m. Seems like I've seen those signs in every bar I've gone to. Coincidentally, this represents how FNHTR occurs 1 to 6 hours after the transfusion. This later onset can be a distinguishing factor between FNHTR and other transfusion reactions, like acute hemolytic and anaphylactic reactions, which both start during or immediately after transfusion itself. Alright, that's it for febrile non-hemolytic transfusion reactions. Let's summarize. Febrile non-hemolytic transfusion reaction, or FNHTR for short, is a transfusion reaction caused by host antibodies attacking white blood cells from the donor. This destruction of donor white blood cells leads to the release of cytokines, which causes inflammation and fever. In contrast to acute hemolytic transfusion reactions, there is no hemolysis in FNHTR. And unlike other transfusion reactions that occur during or immediately after the transfusion, FNHTR occurs slower, usually 1 to 6 hours after the transfusion. That's all for now. On to the next one.